Hey everybody, this is Larry. This is me going with Q3 of the bi-weekly contest 158, maximize Subarray GCD score. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So this one I struggle with the most. I hope you read the problem because I'm not going to explain or like read the problem to y'all here. You know, not a babysitter. But I am bringing out the drawing board. That's why I am pausing a second. Right? I think so the n is about, what is it, 1500? 1500. So the first thing that you have to consider is n squared fast enough, right? So, you know, given n squared or n choose 2 more specifically, which makes it a little bit better because then now you have 1500 times 1500. Which is like 2.2 mil, but over 2 is 1 mil, so maybe it's fast enough as long as you didn't do anything crazy. I did do something that is n squared log n, and that timed out, which is fair enough. I was a little bit YOLO gambling, and I've optimized that away. But that said, that means that n squared is a good setup, and the way that you have it is just that, okay, well, let's say you have an array that is this length, and then now for each of these, you do kind of like a sub thing, right? So then this becomes n squared. So then you just basically iterate on every starting point, and then just kind of go, not a sweep line per se, but just like sweeping things into the set. And this is a very common pattern to get to n squared complexity. Assuming that you can get the incremental cost to be like O of 1, O of log n, even sometimes. Not this time, but sometimes, right? Okay, so then how would I do it? So this part I honestly struggled for a long time. I was trying to play around with this idea or some sort of greedy ideas around GCD, of like, you know, well, we have this doubling function. So if you don't have a doubling function, it's relatively straightforward, right? So you basically keep track of one item or one GCD, and then keep on extending it, right? Because keeping in mind that GCD of say A, B, C, dot is just equal to, you could decompose it of GCD of A, B, and then GCD of this of C, right? I forget what it's called. Is it derivative? I mean, it's a functional programming term too, but you get the idea, right? It's that like, so as a result, as you kind of if you want to say sweep from left to right, you just keep on adding numbers to GCD. You already know the riff as you go along, so you're able to get that very quickly. That's, you know, if you understood all that, it's probably like a 3 to 5 minute problem, right? Maybe even less if you, depending on how fast you type. But the problem is that we have this doubling function, right? And I struggle a lot with this doubling function. I did not really figure out how to do it. I had ideas around greedy solutions and stuff like that. Because I was like, okay, well, you always want to double the smallest number, which actually turned out to be not true, by the way. But that's what I thought for a little bit. And if you watch the live portion, you'll see me like make a lot of different mistakes. Like, for example, 2, 3, you actually want to double the 3, right? Okay. So, and one thing that I didn't appreciate is just the number 2, which goes in the double. The idea then is that that it took me a while to kind of figure out, and I was just like, okay, what if we, because I was playing around with similar ideas about like, okay, and a lot of these ideas, the way that I come up or try to come about them is by playing with a lot of examples. For example, maybe we have, you know, okay, so we already did 2, 3, where you want to double the 3, but similar thing is like 4, 6, right? So you have to double the 6, not the 4, because if you double the 6, then you get 4, 12, and else GCD is going to be 4, right? Where if you double it to 8, 6, it's still, oh, I messed this up? Maybe I messed this up. No, I think this is right, yeah. Where you have this, then it's still just 2, right? So something like that, and I was playing around with it, but I didn't really separate it out until I kind of did a refresh or reload on my head, if you will, by going to Q4. I went to Q4, solved it, and I came back, and I was like, can I do something? And if you see the initial part, I have a lot of the similar ideas, right? For GCD, I thought incorrectly that I just needed to get the smallest number. So then now, given an array, and without loss of generality, because we're going to just sweep one of them, you know, from one starting point, we don't need to kind of prove all the other subarrays. We just need it from here, right? And then the idea I was just keeping is that, well, if we're trying to remove numbers that contribute to the GCD in a negative way, then we just keep track of like the k smallest number, right? Right, smallest number. And then the idea here is that, okay, maybe I have some GCD that's quote unquote inside the doubling, bad handwriting, and then another GCD that's outside, and then try to do some math that way. And it worked honestly for like 820 test cases. I don't know why. I don't know what 820 out of 823 or something like that. And I'm like, Leetcode, what are you doing? Why does it take 800 test cases to have a very basic failure if I was wrong? Anyway, that's another rant for another time. Anyway, but this doesn't really work for the example that I was telling you about, the 2-3 case. There's a case where you have about like, I don't know, 752s, and then 1 3, and then all 2s again. And then now the idea is that you want to double this 3 to get a 6, and then now you have the entire array on just one change, going from GCD of 1 to 2 or something like that. Yeah. Okay, so that was the case that I was kind of trying to work on. And as I said, I went to cube 4 and I came back and I thought, okay, well, actually, using the same heap idea, I can just keep track of the number of 1s, right? Because, the number of 2s, because the number of 2s is the only thing that matter. Because when you double, that means that you have 1 more 2, and then now, if you want to look at this inside in terms of inside outside, you have inside outside, right? Then what that means is that well, now we just have to keep track of the number of 2s, because on both the inside and outside, because here you're dominated by the smallest number of 2s, right? Because basically, if you ignore the other numbers, the number of 2s is the only thing that matters outside of that, because when you double, that's the only thing that gets affected, right? When you double a number, you just increment that number by 1, right? Or increase the number of 2s by 1, and then now what's the GCD of similar idea is that, okay, what's the GCD of inside and outside, right? Well, and just looking at the 2 portions, well, the GCD of inside is just going to be 2 to the smallest number, right? Because if you took the GCD and it's like, I don't know, 1 1 1 1 1 1 2, and then like 2 2 2 2 2, and then the question becomes in another way of, okay, can we, given that we're limited by the smallest number, can we double all the smallest numbers, right? Meaning that, okay, if there are 4 of these and we can double 4 numbers, then now it went from 1 to 2. And that's the only way you can change, right? Because you can't go to 3. If 1 is the smallest number, you cannot go to 3. You don't care to do anything about the 2 because you cannot go to 3. The only thing that you can do, because then the new number is going to be limited by this plus 1, which is 2, right? So then now it just becomes a question of, given that we can change k numbers, how many numbers can we change? And whether that's dominated by that, right? Because let's say here in another case, and we keep track of k inside, so by definition that's enough. But let's say we have a lot of 1s. Let's say k is equal to 5. We have 6 1s. Then now we cannot remove all of these. So then now we just limit it by the 1 2. And that's kind of the idea. I know that maybe I'm a little bit fast and the explanation's a little bit awkward and weird. But let's go over the code and hopefully, maybe that's a little bit better. Yeah. So okay. So there's a bit of GCD math that I kind of assume that you kind of know, which is basically, for example, like I think the other one that I didn't write down, and I'll just write down an ASCII out here. Oops. Is that GCD of A and B, or A times C, B times C is equal to GCD of AB times C, right? I think this is, that's almost by definition, maybe not quite, but almost there, and it is needed, as you'll see in a second, because now we're taking out all the 2's is why this is relevant, right? Okay, so here, this is just a pre-processing, so I could do 2 to the n power without doing it. It's just a lookup. Here, we pre-process every 2. So 2 sub I is equal to the number of 2's in the factorization of num sub I, right? I spelled factorization wrong. Factorization, right? And of course we divided from the original number, so we could do the math later. Yeah. And then now this is just a setup. So for the start of O of n, we kick it off with the g is equal to the first number. That's just like a sentinel value, really. H is equal to, well, this is the heap, but I think I actually end up not using the heap for reason you'll see in a second. But F is the count of the smallest number of 2's inside this range from start to n inclusive, right? And we just start at 0. Outside is I don't think I use outside anymore. I think I used it initially, but inside is the limiting factor, which is the smallest number of 2's a number inside this range can have, right? This is not the count. This is the count, but this is the smallest number, right? And that's basically the idea. Is that then now here we do GCD. This is for GCDs, not counting the 2's, right? Yeah, it's just for GCDs that we don't care about the 2, so we're always going to do the GCD. So that's what G is for. Yeah, because we already took out all the 2's from here, right? And for example, you could, like, what's a case, right? Well, you have maybe like 3 and or let's just say like 9 and 45, right? What's the GCD of that? Something like that, right? So now you have I guess in this case it's just 9. So that 9 is the GCD outside the 2's, and you can't do anything about those because that's just how GCD works for those numbers, right? Like you can't do anything about those because that's just all the number. If you have to do every numbers in the range, that's going to be the GCD not including 2's. And here, this is just a very fancy way of keeping track of of 2 things. The number with the fewest 2's in the factor, right? And that's what the inside does. I say it's inside because initially it was inside the heap and outside the heap. That's how I kind of kept track in my head. And if you watch the live portion of this, at least the very end part, because this is a long video, you'll see how I optimized this. Because initially I did use a heap, and I optimized it a little bit, and I optimized it even more to here, right? And you could see that on the live portion. But yeah, the number of views 2, and that's going to be inside, right? The variable name inside. And then F is just the count of the number with the fewest 2's in the factor, right? It's actually the numbers. It's not the number with the fewest 2 in the factor. It's actually the fewest 2 factor number or whatever. Yeah. So then now this is basically we want to make inside can only get smaller. So if it does get smaller, then we set it to the number of 2's in the current number. We set the F is equal to 1, right? Because we only have 1 of them. Otherwise, if it is equal, then we have 2 of these. And then now, these are the only numbers that we care to increment or doubled up by k using the k operations. So if we have fewer than k, then we just take the smallest number, we add 1, which also means multiply by 2, and that's the answer, and that's the new GCD, and that's the range. And then if f is greater than k, that means that we cannot double up all the smallest number. So then you have just this stuff for the GCD and this stuff on the length instead, and that's it. Yeah. So what's the complexity here? I mean, this is factorization, so this is kind of linear-ish. I say ish because it depends on the range of numbers, if you will, because this is a loop of like, I don't know, 30 for 10 to the 9th or whatever, right? And then this is n, so this is going to be n squared, but everything else is all of 1-ish. Say ish because, like I said, GCD is also, like, you could say it's all of d, where d is the number of digits or something, but yeah. And that's it. Honestly, I thought this was very tricky. It's just hard to come up the right greedy, I want to say. And I didn't appreciate, I mean, the number theory part is kind of tricky as well. I do urge that you maybe watch the live portion maybe faster so you can kind of see my evolution of how I came to this. I had a couple of greedy ideas that were incorrect, which is how I got like 25 minutes penalty. There are a couple of time limit things that were just a little bit awkward, but you know. But yeah, that's what I have with this one. Let me know what you think. Thanks for watching, and yeah, you can watch me solve it live in the contest now. Very unhappy, but okay. That time it looked okay. So, alright. So now we have 2 hard problems. How are we doing on rank? Ooh, not so good. People. I took 8 minutes on Q2. I guess it's just, a lot of it's just typing. It's fine. Alright. Q3. Maximize subarray GDC score. You may perform at most k operations to choose one element. Double is right. Each element can be double at most once, so that means that you could double k of them. The score of the contiguous subarray is defined as the product of its length and the greatest common divisor of all its elements. The product of its length and the greatest GCD. It has to be maximum score that would be achieved by a contiguous subarray from the modifier array. What does that mean? Alright, double 0 to 4, and then now GCD is 4. Okay. How do we get a subarray GCD? Okay, n is only 1,500. That's interesting. Maybe we can do n squared type things. What would that look like if n squared? N squared times k is definitely too slow, but n squared. GCD. GCD. Right, 10 to the 9. That's interesting actually. That means there's no Ceph or prime or anything weird. That means it is n squared then, right? If there's no way to kind of optimize based on num sub I, then it's n squared. So okay, so you have a subarray. How do you choose very fast what to double? Do you always double the smallest number? I guess so. Because by definition, the smallest number the GCD is at most the smallest number. So I guess so. GCD is the smallest number. And you're going to do it once, so that means that you take the case smallest number and then multiply by 2. But you don't have to explicitly do it though, right? It's just that you take the GCD of those numbers. What is the math? What is the math? You want to do that in a sliding window kind of way. What is the math of that? Well, how many numbers do you have to do to change the GCD? I guess that's the question. Right, you only change 1. Yeah, so now you have. So you have So basically you want the GCD of inside and outside. Inside is easier. No, is it? No. I guess they're both kind of hard. How do you do a rolling GCD with changes? You add in the numbers easy, sure. I guess actually outside is easy. But then how do you remove a number from a GCD calculation? You have something like this, and then now this is gonna be G numbers start. Right. So we don't have anything, then this is going to be the answer, right? But that's not quite. But we have to do this K thing, right? 4, 7, 15. How do I do the K thing? Break down the conversation, but how do you remove a number from a GCD calculation? Okay, so you have two populations, right? You have Okay. But the thing is that we're not doing with two unrelated populations. It's just divided by 2, right? On some parts of it. So the GCD of everything inside is just 2 times what it would have been. Because you're always removing the biggest number, it should. Because you're removing the biggest number, it should not affect the GCD. Is that right? I guess so, maybe. I don't know if that's true, but okay. Let's just say. So this is at least something. We could probably remove it, but we have stuff that's okay. Doubled and not right. So can we even do n square log n? Is that too slow? That's like. It feels slow though. We remove the biggest number. What does that mean? Does removing the biggest number ever change the GCD? Yes, but also no, because again we removed it from the. Okay, fine, right? So so we have something like G is equal to 1, then we break, just because if that's the case, there's no way to get it anyway. But otherwise, we have inside. I don't know if a heap is good enough though. It feels a little bit too slow, but even 1,000 it would feel a little slow, and is equal to 1,000. But we want a max heap. right? So everything inside the heap is doubled. So maybe we have a GD. Can K equal to 0? K cannot equal to 0. So okay. I don't know. I want to say. Alright, just start it off here for now. I guess it can go higher though, right? Because you can say, so if within you go from 2 to 3 to 2 to 2, well, GC of 2 to 3 now again, because it goes outside, it still is the case. I mean, it's going to be 1 on the inside, but then when the 3 goes outside, it's still going to be 1. That's why, Larry. Stop. Keep on doing this. Okay, fine. Okay, so yeah, fine. Is it going to... Okay, so... So that's the doubled. We pop out the number. G not double. Yeah, this is so awkward. I don't know. There's like no good sentinel value. That's why like I'm struggling a little bit. Okay. I guess I have to just do it this way, even though it is very awkward. Oh wait, no, this is not true. It's not yet. Okay, so these are the doubles, and then now not double. So then if length of heap is greater than K, then we pop it. My period not working. X is equal to, and then now G is equal to GCD of G and X, right? Only if G is equal to 0, G is equal to X. It's kind of awkward, like I said. That's fine, right? And then now we have GCD of GD times 2 and G. And then we have this thing, right? Best is equal to F max, best times n minus so plus 1. I'm not confident about this at all. But let's give it a spin at least. 8, 14, 15. All right, let's give it YOLO submit. There's so many things wrong with this. It could time out. It could just have a wrong answer. So let's kind of, So yeah, so a lot of places, a lot of potential wrong answers. Oh, okay. The answer is 2. I put 2, but we can put the entire thing inside. Oh, because I put, if it's equal to 1, I break. And that's not true though, right? Okay. I thought I could do like an early termination thing, but maybe not. Maybe I can do this. Because the thing is that if I don't do this, I'm worried I'll time out. So maybe it's a premature optimization. I mean, I know that. I mean, that's why I put it in, but I didn't think it through that much for obviously this case reasons. We'll see if it times out without it. 818 out of 823 though. But now we're going to be much slower for cases like, well, the other cases. So it might time out. We might need to do something like this and then still, oh, okay. Actually, that's a little bit unexpected. I was worried about timing more than anything. So okay, let's just say we don't have this for now. I mean, this is basically the same case, but now with, oh no, it's only one modification. With only one, then you have all the numbers. GCD is 2 times we just take all the numbers, and then the GCD is 2 times the length, right? I feel like we're mostly close, but clearly not. But yeah, I mean, this is gonna not give me anything useful, I don't think. But maybe like oh, I mean, it's just gonna be like too many prints. Oh, it doesn't. Yeah, there. But why is it saying 1500 though? And then start. Oh, I guess it just became best once earlier on. No, I mean, I guess that's fine. Yeah, it should only happen once. And then, but it goes up by 2. It's the product, it's the length times the product. Or the GCD. Why is GCD? Oh, because G is 0. Because we haven't done it yet. That's why. Because we have. No. Why? Yeah. Why? Alright, let's point it out. That's actually no. Yeah, I think my understanding is a little bit off. How many people? Oh, people got it very quickly. I mean, even if they were cheating, it's still. Maybe that is not a still, but 1500. So GCD is. So that's 2. Why is N and start? Oh, there's 2 2's here. So 1 1. Why is it 1? These are all 2's. Why are they 1? Did I mess something up earlier on? Well, I mean, I guess this is the one that. I don't know. All right, let's see. I feel like I'm debugging something dumb. Okay, output limit exceeded finally, but okay, fine. If best is I don't know. Okay, still output exceeded. Does it actually print stuff at least? Where do you get 9,000 from? Is that? And k is equal to 1, say. Okay, so you have to okay, so that's best GCD. How do I even get 3 as a GD? That doesn't make sense, right? Am I looking at the right cases? Oh, what the? Where did I make this? I don't even know when this happened. G. I probably just like typoed it, but oh, this is GCD of GD and nums of n. I think that's what it used to be. That'd be funny if it works now. I don't remember what I did, honestly. I don't even know what to. No, it's still 1500. Okay, that's good in the sense that like I'm not losing my sanity. But okay, so here the length is okay, but it's 1 1 for some reason. G. What is that reason though? Let's go way back. Okay, so the length is 700. But then at a certain point, after 750, is there? Is it not all? Oh, maybe I misassumed the input. Maybe there's like a 1 in the middle, like 750 in the middle, and as a result, you're supposed to double the 1 in the middle. Maybe that's how they try to get you. Maybe I just misunderstood the input. Okay. Right, so do. Is there? No, maybe. I don't know. Why else would it be at 750 though? Oh, there's a 3 here. Oh, I see. So because there's a 3, they want you to double it. So, oh wow, that's a how am I handling it? I see. Maybe my so okay. So there's a 3. How am I handling it? Goes to then the GCD of what's inside. We only have 1, but we always want to remove the biggest. Oh, but we don't always want to remove the biggest. So that's the assumption that was wrong. Is that we remove. So we have the 200, but then because you don't want to remove the biggest. In this case, you want to remove this. You want to double the 3 and not double. So okay, so I was wrong in that you always want to remove the biggest number. Okay, greedy doesn't work in this case. But okay, how do we do it then? What does doubling do? Doubling has 2 things. One is doubling the GCD, okay. The other is it a special case or So then okay. How do I want to think about this? Basically, okay, doubling means giving a 2 to the GCD. Okay. I mean, and if you double everything, then you have 4 and a 6 instead. You still want to do the 6 to 12 to get the 4, right? So it's not just like an odd even thing. That's a good case. I don't know how I would formulate it. I almost want to like binary search on the answer, kind of, but not really. Okay, let's say we have the answer without all this crazy doubling thing. And then what? And then basically the answer can only be either the best answer or doubled, right? Okay, maybe. I mean, I always submitted twice, so I guess there's a record of this, but so I don't have to copy and paste it to another thing. But okay, so let's say we have. Let's go back to the beginning, right? Let's say we have something like this. Okay. And then now the only way that we improve is just by is it times 2? Yeah, because if you add in a multiplier, so right, so then here for start, maybe we go again. Let's say num sub start for n in range of start n, right? We go, okay, well, basically, well, first of all, what you want is if GCD of G num sub n, if this is less than best, then let's try it and YOLO. Okay, so used is equal to 0, and then if this is the case, then we just say we used 1, and then G is equal to GCD G num sub n times 2, else G is equal to right? Otherwise, also, and used is less than K. Yeah. Okay, otherwise, if G is less than best, then we just break, because adding more numbers is not going to help. Right, so yeah, I think maybe that's an idea. What do I have? 4. Okay, didn't help for this one though. The answer is, oh, because we want to double both of them. Oh no. Oh, this breaks too early because I forget that because best is not, best has the product. So okay, fine, let's do it this way then. Best is not the GCD, Larry. So how do I best GCD? Maybe, I don't know. How do I greedily use this in a way? We could do it, keep track of the best per length. Yeah, I think we could do best per length, maybe. Keep track of G, right? Okay. And then now we can say best of n minus start plus 1. I don't know that this is any better, to be honest, but okay. And then now say answer is equal to 0, and maybe answer is actually max of best. Oh no, that's not right, because we have to do the length. So okay, so right. Best of L times L, something like that, right? So then now here, I'm just like, I'm not confident about this at all, to be frank. And let's see what it, so now G times n minus start plus 1, right? Something like that. Oh, outbounds. Yeah, okay, fine. Because it could be exactly n, and there shouldn't be 0 elements, but I guess I'm lazy. Alright, this is still no bueno. I'm still getting the 8 wrong. Why am I getting the 8 wrong? 2, 4. So that means that here it would let's print it out. Okay, so oh no, not that best. Okay, you have 0, 4, 2. So it's gonna be 4 times 2. So for one element, okay, fine. But we want two elements, it's 2. 2 times 2 is 4. But we want this is wrong on the first calculation. I think that's why. Because we double it, but we don't count it because of the existing G. How do I handle that? No, I guess we could just start it like this actually. Alright, 8 is fine, but then now the 10 is not. What is 10 again? Oh, the 7 times 2, so it's gonna be 14. So okay, so that's fine in a way. Because we definitely do not handle it because of this weird thing. So it goes 14, if G of 7, this is 7, and best of whatever is, how come I don't print best? I don't, oh no, I do print best. One element is going to be 7. So then now we try to use one, we double it. So this should be G is equal to 14, right? Why not? Oh, because it's not less than, it's less than equal to. I guess less than equal to is fine, maybe. I don't know. 8, 14, 15, 3000, 3000. Is 3000 right for the other one? I forget that honestly. Oh yeah, because you doubled all the numbers. Okay, fine. Am I confident about this? Not at all. Not at all. No idea. Okay, YOLO submit. May even still be too slow. We're so, I mean, we're like 3 inputs out the wrong answer, but still no bueno though. But oh, then I don't know, honestly. I mean, this is way more incorrect. It seems like I was hoping this greedy would maybe work, but it may be that this greedy is no bueno. But why is that? K is equal to 3, meaning that we just basically doubled all the numbers. Oh wait, yeah. But why do I have this number? What does this mean? Okay, so this is the number from this. Is that right? That doesn't seem right. Right? Because that's a way bigger than the expected answer. Oh, I'm dumb. How did this even... Wow. How did this even pass 70 cases, actually? That is astonishing. Okay. But now this is wrong again, which is a little bit sad. But that's fine, right? At least, you know, but this is right. How did that pass 80 cases? I literally just didn't... I mean, I guess here maybe kind of faked it out. But okay, so how do we fix the 2 cases? I do still print best, so one element is going to be 3, and then it's all just 2 until 750 or so, probably. Okay, so then what? That means that now we start at oh, because of this equal sign. Because of this equal sign, because it doesn't improve it when it's equal, but if I don't do it, then I don't get the... How do I try to improve it? Maybe I have to do two equations. I think there's one here, and then maybe just something like if n minus I would say we want to double all the numbers, but we want to double all the numbers except for one. Like, what if they're all okay? You have a 4. Is this right? But what I want to say is that, okay, so you have this answer. That means that the best answer can only be answer times 2, but I think I also need this to be okay. So maybe I have something like this, and then else if GCD this is so hacky at this point though. Yeah, I mean this is still wrong for this one though. Why? So it goes 2, no double. Basically, we don't want to double anything. This never happens until here. Then we used one, right? Why is this not right? I'm spending way too much time on this. Okay, so then it's gonna be 2, right? So then now this is gonna be 2, 2, 2, 2, 2. Okay, right, so because we already used it for some reason. I guess that's the answer. Oh, because of this thing, we used it on the first possible thing. Yeah, this thing is not cutting it. Yeah, this is not cutting it as we saw. But then now, I don't know what the. They not just like tell you what? Okay, because you print too much, they don't tell you anything anymore. Yeah, I just want to see what my outputs are. Okay, so yeah, so this now. For a given length. I don't know. I don't know that I know how to do this one. Maybe. How many people got this one? Seems like a lot of people. Very quickly too, even if they were cheating. Am I missing something obvious? And it's gonna be either the answer. That's not actually true. It's not just answer and answer times 2. Because there could be a slightly suboptimal one in which you optimize away, right? So then for each L, you can only really go to L times 2, I think. Is that even true? I don't know. A 4 and a 3, and you want to double the 3, right? Okay. But you have a 4 and a 6, or a 2 and a 3. You still want to double the 3. How much time do I have left? Half an hour. I feel like I should skip ahead just because I have no idea. I feel a little bit bad though. Am I close? I mean, this hack doesn't even fix the this case. It's just like very wrong. But that's because I don't handle the case where we use the doubling on all or as many numbers as we can to double the answer. How am I thinking it wrong? All right, let's. All right, let me refresh. Maybe skip ahead real quick. We have Q4, maximum good sub. We got this one. That's good. How much time do I have left? I have 18 minutes left for Q3. Am I thinking about it weird and wrong? Probably. What a silly mistake, though. I don't know. There's something to do with twos. Maybe it's the same what idea of the heap. But instead of doing this heap thing, just keep track of inside and outside with the twos. I have 17 minutes. Okay, I mean, this thing is fine, maybe. We're just doing nothing, right? So, okay, fine. I mean, it's not great, but it's fine. I mean, it doesn't do anything, but it's fine, right? So, okay. And then now, we want to say, okay, so then, I think it's the same idea. Okay, we have a heap, right? So you want the GCD outside. Oof. How do let's say we keep track of the number of twos. I guess that's the thing we care about. And then it's just the GCD outside of the twos, which can or right. I don't even know if I would care for this, but okay, fine. I mean, I think we can do something similar to this idea. How would that look like? Okay, maybe I just have something like that. Okay, oops. We could pre-process this, right? Okay, right. So then now what do we do? So then now we have the same idea, right? Oops. So basically we want to keep the smallest in there because then we want to double all of them, right? And by doubling all of them, it just means +1, right? So that means that we have a heap. We want to say, okay. Yeah, and now all the numbers are already processed. So G is going to be, G is equal to D nums start, oh sorry, nums of N, G. We want to say the number of 2's is going to be just limiting by the smallest number, which is the number of things inside the heap, right? Yeah, because everything outside the heap will have, but then you have to do a GCD on that, so you have to be careful. I think that's all, but I think the idea is basically the same, maybe. Yeah. So we want to remove the min element. No, we want to remove the max element because that's fine, right? So then outside the max, okay, so then you have outside is equal to, I don't know, just some big number, it doesn't really matter. Outside the doubling, and then here we want to remove the min. No, we want to remove the max. So then sums of N, right? And that means that H sub 0, let's just call it inside is equal to this. So that's the number of 2's on the inside, and you want to double everything on the inside. But before that, let's do the if length of H is greater than K, X is equal to and then outside is equal to min of either X or the outside. So that means that it gets smaller maybe as we pop. Yeah, I mean that's just the number of 2's, right, on the outside. Okay, so this is the number of 2's on the outside of the doubling. Yeah, and then okay, and then inside you go to this, which we always have anyway. And is K always, K is at least 1, okay. So then now F min of inside outside, that's times the power of that, or power of 2 to this, right? Yeah. Actually, maybe I want to write it like this notation to be slightly. Yeah, and outside will dominate, so then you have this. So that times the GCD, or G times n minus, why did I say with, start +1, and best is equal to F max of this. Someone like this, right? Do I have all my encodes up? Alright, well, that's definitely. Oh, actually, I don't know if that's wrong. I forget what the right answer is anymore. 36. Oh, no, the new input tells you. That's kind of nice. Okay. Definitely very wrong, but I think something like this is maybe right. Okay, so 4. GCD. Oh, it's inside +1 because of the doubling. Does that fix it? 8, 14, 15. Oh, wow. Is that it? Alright, I mean, I've YOLO'd on less. If it times out, I'll also be sad though. Like maybe we could have optimized this part. I think that's the part that, I don't know, it's a little bit not so great. But everything else is a heap. Oh, huh. Expected 3000. I guess these are all primes. But I'm returning like a ridiculously big number too. It's not even close. Why is that? 3000 suggests that we can double all the numbers. What is the GCD outside? Why is the GCD so bad? Let's see. Yeah. Let's say if. Yeah, I mean it's fine. It's I don't even know what the. We have 8 minutes left, so I might not make it. Num sub 1. What? Oh, I meant this one. But okay, start N and G. Okay, it should be all ones. So where does it get the? Inside, outside? Am I doing something wrong? Inside, outside? Inside should be all. Or the smallest. Damn. No. Oh, I'm dumb. I'm removing the biggest, but this is not the smallest that's inside. The smallest number is the choking point. So okay. We okay. I don't know how that didn't catch more cases. Again, 819. What do they have 800 test cases for? But okay, fine. What is the smallest number that's inside? I guess the smallest number will never get changed, so we can maybe do smallest inside is equal to whatever, right? And then now I guess just call it inside really. And then inside is not equal to this, it is equal to the thing that we just put in, which is 2 sub n. Yeah, I guess we don't need to print this because this thing is kind of running a little bit slow. So result. Okay, so this everything else still looks good. I don't know how that passed so many test cases, but I think this is the one that I don't remember. The other. Okay, so let's YOLO submit. Hopefully not too slow. We have 6 minutes and 30 seconds left on the contest. So if it's too slow, it'll be very sad. I think this is the only thing I should be able to optimize. Probably could have done it honestly, but I guess I could write this to begin with. Yep. 822 over 823. We'll put it in here. Let's run it real quick. We have 6 minutes. I think we should be able to get this, unless Leetcode is just being unreasonably silly. This takes 1.3 seconds. Let's see what happens when we do that. Let's see, it was 1, right? So fly in range of, what did the numbers go up to? 109, so just whatever, 35. P dot append was 1 times 2, and we should be able to go ooh, what the P of this Is that faster? Oh no, it's slower actually. I mean, this is actually what I worried about, the n square log n. Can I do a little bit faster? 5 minutes. I don't know if I could get it right in time. We remove the max. The max doesn't matter because the max is outside, so we can remove this. Because by definition, the max is going to be whatever, and then inside plus 1. No, this isn't right though. I mean, it may be faster, but I think I'm off by a little bit. I think the thing is that we have to check that. Oh yeah, outside. So then here it's kind of right, but because outside has to be. Was it that much faster? No, not really. Okay, so we kind of need this, but. So can we get rid of the heap? I have 4 minutes to get rid of the heap. Because we have to count the number of things. So another way to do it is just by having a frequency of the smallest number, right? Okay, fine. I don't know that I have time enough for this, right? So it's not a heap. We go f of 2 sub n increment by 1, right? So then now we go, okay, what's on outside, right? Well, inside is just the smallest number, so that's this, that's fine, right? And then, but then now this is, okay, can we double all the smallest number? So if f of inside, or f of inside is less than or equal to k, then we can do inside plus 1 because that means that we can double all of them. Otherwise, then we do just inside. Yeah, because that's the smallest number, right? And then now we got rid of the heap. Got rid of the heap, but it's still not as fast as I would like, honestly. Is the answer right though? I think the answer's right. I forget what. Oh, they don't tell you. That's why. I was like, I don't remember this. I'm gonna go to submit because I have 2 minutes and 30 seconds and no other reason. I don't have time. But we got rid of the heap, so it should be faster. We don't need the outside anymore. F. We don't even need that. We can maybe replace this with a count, right? So F. Okay, we got it. Okay. Whew. With 2 minutes and 11 seconds to go. That's tight. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, today's contest, everything in between. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye-bye.